Hello students, this is a very important session in which we are going to discuss the SI system and then we will discuss the definition of the standard units of various fundamental physical quantities, right? As we have discussed in the previous lecture that there are various system of units starting from CGS, FPS, MKS and then SI. SI is the latest system of unit which we do prefer over other system of units. In SI, in addition to those three basic physical quantities, I am talking about mass, length and time. In addition to those three, four more physical quantities are included in SI as basic units. And in addition to 7 basic units, SI system also comprises of 2 supplementary units, right? So let's discuss it. So in SI, these are the 7 fundamental physical quantities and these are their respective fundamental units. Mass is kg, length, SI unit is meter, time, its SI unit is second, temperature, its SI unit is Kelvin, electric current, its SI unit is Ampere, luminous intensity, its SI unit is candela, and amount of matter, its SI unit is mole. So these are the symbols used to denote these fundamental units. So these three, mass, length and time, are common in all the 4 system of units, right? But I told you, these physical quantities, the first 3, were found to be insufficient in expressing the laws of physics in various other branches of physics besides mechanics, right? So there arises the need of the other physical quantities. So these are the 7 physical quantities having their respective units, which are known as the fundamental units, right? And in addition to these 7, these are the 2 supplementary units. Plane angle, its SI unit is radian. This term will be used in 2 dimensions. In the case of a circle, the angle subtended by an arc at the center, that is plane angle. Solid angle, this will be the term used in 3 dimensions. Consider a closed surface at a point at the interior, the angle subtended by any portion of that closed surface is the solid angle. So SI unit of plane angle is radian, SI unit of solid angle is steradian. So without wasting any time, let's start discussing how to define these units. We'll start with kilogram, that is kg. And here I am not talking about the normal definitions, we are talking about those definitions of these fundamental units which were adopted by General Conference of Weights and Measures. So the definitions which we are going to discuss, they are accepted by the international community, they are universally accepted. There are no ambiguity in those definitions, right? So let's start with kg. We are aware mass is the amount of matter contained in a body. So 1 kg actually is the amount of matter contained in a platinum iridium cylinder kept at International Bureau of Weights and Measures at Sèvres near Paris, France. So 1 kg is the mass of a platinum iridium cylinder which is kept at International Bureau of Weights and Measures. It's at Sèvres near Paris, which is in France. So that's the standard definition of kg or kilogram, right? Next, we move on to length. Its SI unit is meter. Now, in 1960, General Conference of Weights and Measures defined meter on atomic standards. As per atomic standards, meter was defined as the distance occupied by 1650763.3 wavelengths emitted in air or vacuum of orange-red radiations by krypton 86 atom. 86 is the atomic mass. So this is on atomic standards. So this definition of meter on atomic standards is defined as the distance occupied by 1650763.3 wavelengths in air or vacuum emitted by krypton 86 atom. So this is the definition, right? There is another very interesting definition, and this definition was given by General Conference of Weights and Measures in 1960. 23 years later, in 1983, it was redefined. The meter was redefined in terms of speed of light. We all are aware the speed of light in air or vacuum, it's given to be 3 into 10 raised to power 8 meter per second. This is the speed of light in air or vacuum. We all are aware light travels with different speeds and different medium. In air or vacuum, the speed of light is maximum, which is 3 into 10 raised to 8 meter per second. But students, do you know that it is just the approximate value? The exact value of the speed of light is 299,792,458 meter per second. This is the exact value. You need to remember this. This is the exact value of the speed of light. Now, why you need to remember this is because now the definition of 1 meter will be defined in terms of C. So look, how to define it. Let's find the logic behind it. We all are aware of this formula. Distance is equal to speed multiplied by time. We all are aware of it, isn't it? Now we want to define 1 meter. So distance, it should be 1 meter. Light traveling in air with a speed denoted by c. Suppose time is considered to be 1 by c of a second. So cc will get cancelled. The answer would be 1 meter in SI. So that's the logic. So in order to define meter, we will make use of this particular logic. Now it will be very simple to define 1 meter. Now look, again, in 1983, General Conference of Weights and Measures defined meter in terms of the speed of light. So in that respect, 1 meter is defined as the distance travelled by light in air or vacuum during the time interval 1 by c, that is 1 by 299,792,458 of a second. This is the definition of 1 meter, right? So again I am repeating, 1 meter is defined as the distance covered by light in air or vacuum during the time interval 1 by 299,792,458 of a second. So this is the definition which was adopted in 1983 by General Conference of Weights and Measures, right? So that's the definition of time. Actually, that's the definition of meter, right? We have discussed meter. Now, we will discuss the definition of time. Definition of the SI unit of time, which is second. So, what to do is, again, second is defined on atomic standards. It is defined in terms of the vibration of cesium-133 atom. So, second, in 1964, General Conference of Weights and Measures defined second on atomic standards in terms of vibrations of cesium-133 atom. Atomic clocks are based on this only, right? So let's concentrate on the definition now. So 1 second is the duration of 9,192,631,770 vibrations. You need to remember this. 1 second is defined as the duration of, it's the unit of time, so it must be denoting the duration, the time, passage of time that has elapsed. So 1 second is defined as the duration of 9,192,631,770 vibrations of the radiations emitted between the two hyperfine levels of cesium-133 atom. Cesium-133 atom. So 1 second is defined as the duration of this much vibrations corresponding to the transition between the two hyperfine levels of cesium-133 atom. So this definition is based on atomic standards, and it was defined way back in 1964. Again, obviously by General Conference of Weights and Measures. So that is how second is defined. Now coming to this, Kelvin, fourth one. Kelvin. Again, in order to discuss the SI unit of Kelvin, basic understanding of triple point of water is required. Now, triple point. Look, water can coexist at equilibrium in the three states, that is gaseous, solid as well as liquid. But for that, a particular condition is required. So that condition or that state of equilibrium in which water exists or coexists in all the three states, solid, liquid as well as gas, that is known as triple point of water. And the thermodynamic temperature of triple point of water is 273.16 Kelvin. It is equal to 0.01 degrees Celsius. So this is the temperature at which the water coexists in all the three states. Along with the temperature, there is a particular pressure which is also to be maintained, a unique particular pressure, and that value of pressure is 0.46 centimeter of mercury column. Look, pressure we'll discuss in the subsequent chapters. Pressure is expressed in terms of height of liquid column. So here, if the pressure and the temperature are maintained at this value, then the water can coexist in all the three states, and that is known as triple point of water. So why we are discussing this? It's because Kelvin is defined in terms of thermodynamic temperature of triple point of water. Now look, 1 Kelvin is to be defined. Can we write it like this? This is the thermodynamic temperature of triple point of water. If I multiply by 1 by 273.16, then it will get cancelled. So it will give us 1 Kelvin. Simple. So how to define 1 Kelvin? Look, 1 Kelvin may be defined as 1 by 273.16 of the thermodynamic temperature of triple point of water. Right? So this is the thing which you need to remember. So that is how Kelvin is defined. Right? Now let's come across the definition of Ampere. Again, in order to understand the definition of Ampere, you need to have some basic concepts of the force exerted by current carrying wires upon each other. This we will study in +2, but now in order to remember the definition of Ampere, I need to tell this. Okay, these are suppose two straight infinite long parallel conductors, and suppose current I1 and I2 are flowing in these two wires, and they are separated by distance r, and they are placed in air or vacuum. Whenever we consider the case of two parallel wires carrying current in the same direction, then they tend to exert an attractive force upon each other. Right? While on the other hand, if you consider the same two parallel infinite long straight conductors but carrying current in the opposite direction, then it is found they exert a repulsive force upon each other. And the magnitude of that force per unit length is found to be this formula. We'll do it in next higher class, that is +2. But for now, in order to define Ampere, you need to remember this formula, right? The formula is force per unit length Here is 2 into 10 raised to minus 7, I1 into I2. These are the currents flowing through these two parallel straight infinite long conductors divided by R. This is the formula, right? Now look, my intention is to define 1 ampere. So how do you proceed? Let I1 equals to I2 is equal to I, say, and suppose R is equal to 1 meter. I am considering these two straight conductors to be placed in air or vacuum, right? So if we substitute this value over here and also consider force per unit length to be 2 into 10 raised to minus 7, its SI unit would be Newton per meter. So if we substitute all these values, F by L, 2 into 10 raised to minus 7, 2 into 10 raised to minus 7, it will get cancelled. R is equal to 1. So what do you get? I1 into I2 is I square is equal to 1, which implies that I is equal to plus minus 1 ampere. And this is what we require. 1 ampere is to be defined. So it is defined by making use of this mathematical expression. This is the mathematical expression which we are supposed to make use of, right? So students, let's try to define 1 ampere. Look, 1 ampere is that current which when flowing through each of the two straight parallel infinitely long conductors placed in air or vacuum at a distance of 1 meter from each other exerts upon each other a force of 2 into 10 raised to minus 7 Newton per meter of their lengths. So that's the definition of ampere, 1 ampere. Again I am repeating, please concentrate. And the force I am talking about may be either attractive or it may be repulsive. It may be either attractive when the currents are flowing in the parallel direction, then the nature of the force is attractive, and when the current in the two conductors are flowing in the opposite direction, then the nature of the force must be repulsive, right? So 1 ampere is that current which when flowing through each of the two straight parallel infinite long conductors placed in air or vacuum at a distance of 1 meter from each other exert upon each other a force of 2 into 10 raised to minus 7 Newton per meter of their lengths. So I hope by using this mathematical expression you will be easily able to remember this formula. Students, I believe, learn theoretical portion also logically. Avoid any sort of cramming or rote learning. Think logically. Even in theoretical portion, theoretical definition, try to think logically and then you will be able to recall those definitions, right? So, we have defined electric current. Sixth one, luminous intensity. Actually, it is the term associated with a source. It is a property of a source of light. We'll discuss it in +2 in ray optics in detail. But now let's try to define luminous intensity. Now look, luminous intensity in a given direction due to a source is that amount of light which emits a monochromatic radiation of wavelength or rather of frequency 540 into 10 raised to 12 Hertz. And this monochromatic radiation so emitted must possess a radiant energy or radiant intensity of 1 by 683 watt per steradian. Steradian I have told you, that's the SI unit of the solid angle. So I am repeating this statement. We will discuss it in detail in +2. But one candela, for now just try to remember this formula. One candela is the luminous intensity of a source in a given direction which emits a monochromatic radiation. Monochromatic means a radiation having single wavelength, which emits a monochromatic radiation of frequency 540 into 10 raised to 12 Hertz and of radiant intensity in the given direction as 1 by 683 watt per steradian. So this is how candela is defined, which is the SI unit of luminous intensity, right? Mole, I think this is a familiar term, you must be knowing about it, right? Mole. In chemistry, you must have done it in detail, this topic, isn't it? So how to define mole? It is basically the amount of substance that will contain as many elementary units as there are atoms in 12 gram or 0.012 kg of C12, right? So 1 mole is defined as the amount of the substance that contains as many elementary units as there are atoms in 12 gram or 12 divided by 1000, that is 0.012 kg of carbon 12 atom. So this is the definition of mole. So we have discussed all these 7 units, basic units, the definition of all these 7 basic units, right? Do remember those numerical values, the exact speed of light, the triple thermodynamic temperature of water. Then we have discussed the duration of that. In order to define second, we have discussed the duration of 192,631,770 vibrations emitted by cesium-133 atom. Then the distance occupied by 1650763.3 wavelengths corresponding to the radiation emitted by krypton-86 atom. So please do remember those numerical values. They are very important from competitive point of view. In medical entrance, it is oftenly asked, right? So these two are left, supplementary units. One is the radian, the other one is steradian. As I told you, this is a term which we make use in 2 dimensions, like a circle. This is a circle. This is center. This is the arc. Suppose the circle is of radius r. And let us consider the length of this arc is L. This is the angle subtended by the arc. We are aware of this formula, isn't it? Angle is equal to length of the arc divided by radius. We all are aware of this particular formula, right? So theta over here would be equal to L by R. Now look, we need to find 1 radian. Again, make use of your simple common sense. So it will be 1. 1 radian is to be defined. Theta would be equal to 1 radian. Theta would be 1 radian when L is equal to R. Simple. When these two becomes equal, then theta would become unity. So this is how 1 radian can be defined. So 1 radian is the angle subtended by an arc of a circle at its center when the length of the arc becomes equal to the radius of the circle. Very simple definition, right? Next is solid angle. I told you this is the term we make use of in 3 dimensions, like a closed surface. So imagine a hollow sphere over here. This is a hollow sphere. This is center. Consider a small portion of the sphere. Now, these are the points on the edges of that portion. So join these lines, the points on the edges of that portion to the center of the sphere. So a cone type formation will take place in space. Isn't it? So this angle in the space is known as the solid angle. This angle in the space, 3D, is known as the solid angle. So suppose S is the area of this portion, the shaded one, and R is the radius of the sphere. Then the solid angle, small solid angle, it is represented by D, this symbol. So small solid angle is given by area of the surface, small portion under consideration divided by square of the radius of the sphere under consideration. This is the formula. Now look, again, we need to define 1 steradian. So if these two becomes equal, then it will be 1 steradian. If area of the portion of the surface becomes equal to the square root of the radius of the sphere, That is, if these two becomes equal, then solid angle would be equal to unity. So in SI it would be 1 steradian. So solid angle subtended by a portion of a sphere at its center is said to be 1 steradian when the area of the small portion of the sphere is equal to the square of the radius of the sphere. So this is how 1 steradian may be defined. So students, this was a purely theoretical session. So in this we have defined the standard definitions of 7 fundamental units along with 2 supplementary units. I hope you have understood it properly. And again I must remind you, please share my YouTube channel with all your colleagues, with all your friends. If they like it, then ask them to subscribe my channel, so that whenever I upload any video, you will be able to receive the notifications. Thank you.